here's what we're going to do. We're going to go over a few different shortcuts, or what I like to call physics hacks, so you get a better general feel for how to approach a problem. Sometimes just knowing a little bit about a problem helps, and so I'm going to help you learn a little bit about a little bit. All right. So when it comes to projectile problems, so there's two very common scenarios, one in which you're going to drop something from some height h, and we'll take a look at that scenario here. Let it be like that, and we'll say when we drop something, v initial equals 0. Okay, this is important because if v initial is 0, that means the equation change in height is equal to 1/2 gt squared plus v initial t. Gets very simple because v initial is 0, so this whole thing goes away. That means we're only dealing with this equation right here. So that means we can say the change in height. If we know the height, that's an easy scenario, right? But if we don't know the height, we know the time, then we can figure that out. So finding the height is equal to 1/2 gt squared. Simple. So v initial is 0. The height that it falls is equal to negative 4.9, 1/2 g, times t squared. So if it falls for 2 seconds, this is about 5. 2 squared is 4. So 5 times 4. So height that it falls for 2 seconds is about 5 times 2 squared is 4 is 20 meters. Okay, so this is the deal where if you just imagine this is 5, so 5t squared. If you drop something, the height that it goes is equal to 5t squared. So at 1 meter, or 1 second, 1 second drop, 5 times 1 squared is 5 meters. So 2 second drop, 2 squared is 4 times 5 is 20 meters. 3 seconds, 5 times 3 squared is 9, 45 meters, etc., etc. Okay? So that's an easy hack, is just knowing that if you drop something, you can consider 5t squared as the way to find the time, or find the height. So if you know the time it takes to fall, you can find the height that it fell from. So if it falls for 3 seconds, 5t squared is 5 times 3 squared, which is 5 times 9, 45 meters. Okay? Now let's rearrange that equation. I'm going to rewrite it here. Because we already know v initial is 0, so we can leave that part off. I'm just going to leave that off. I don't know if my eraser is going to erase my typed in text, but we'll see. So now let's consider, what if we just know the time that it falls? Can we figure out the height? So no, I mean we did the time. Well, if we knew the height, will we be able to figure out the time? Okay, so let's consider that. So it takes a while to erase, so we're going to go back to pen. We're going to write here, so v initial is 0, so from the drop. So an object is dropped from rest at a certain height. It takes time, that'll tell us the height, but what if we know that it's dropped from a height that we know? So change in height, and remember, change in height starts at its final minus initial. Change in anything is final minus initial. So height final is 0, and height initial is some height, h. So delta h is going to be a negative number if we're starting up here and we drop down, so it's going to be a positive number if we start, let's say, here and launch up. Anyway, so delta h here is a negative number, so that's equal to 1/2 g t squared. And g is negative, so the negatives would cancel each other out. So now your negative height and your negative g are canceled out, so now we're set. So if we multiply both of the sides of the equation by 2, so 2 delta h gets, this 2 gets rid of the half, and then 2 delta h, and then divide both sides by g. So we're dividing both sides by g. Now the g cancels out, so 2h over g, remember these are both negative, so that's going to cancel out. is equal to t squared. So the square root of 2h over g is equal to the time. All right? So that's hack equation number 2. Hack equation number 1 was the change in height is equal to 5t squared if you drop from 0. And then the time for the fall is equal to 2h over g. So if you know the height, 2h over g will give you the time. Okay? Those are the hacks for a vertical drop. 2 hacks. So get to time, get to height. Now, for a launch, there's a few different hacks. So V initial will give you some indication about how long it's in the air until it gets up here. At the top, that point, the highest point, velocity is 0. And we also know that the time on the way up is equal to time for the fall, or time for on the way down. So time up equals time down, time launch equals time fall. You get the gist? But V initial is really going to be the key. So let's say we have something launched at 30 meters per second. I'll show you the equation is to say, let's just consider how high will it go? Or how long will it take to get to the top? How long will it take to get to the top? Okay? So the equation that's driving my thinking here is acceleration is V final minus V initial divided by time. So if we're asking how much time will it take to get to the top, let's rearrange the equation. Time is equal to V final minus V initial over A. What's V final at the top again? V final at the top equals 0. So that's 0. So that means T equals V initial over A. So remember, if A is, for any projectile, A is G. And so we can take V initial divided by 9.8 or V initial divided by 10. We'll rough in, this is meters per second squared. So it's about 3 seconds to get to the top. So if it's 30 meters per second, it's going to take about 3 seconds to get to the top, about 3 more seconds to get back to the bottom. Incidentally, another quick thing to understand here, that should be a straight line. Velocity on the way up here, V here, is equal to velocity on the way down here. So at any point at the beginning, V initial is equal to negative V final. So this velocity on the way up is equal to this velocity on the way down. This velocity on the way up, and if we drew another line here, the velocity at this point on the way up would be equal to the velocity at this point on the way down. So that's another hack to understand. Not only does the time on the way up equal the time on the way down, the velocity on the way up at any height will be equal until you get to the point in the middle where they're 0. Okay? So that means you can take V initial divided by 10, and that will be the approximate time to the top, to its maximum height. That means if you take 2 times that value over 10, will give you time total. So total time of flight is the 2. Now let me show you another thing. Let's go back to our original equation here. Let me erase some stuff. I think I can go a big eraser here. Large eraser. We can erase some of this stuff. Let's imagine a scenario in which let's get rid of all this here. Okay. You can imagine a scenario in which the velocity on the way up is equal to the velocity on the way down. So that means we can go say, all right, that means acceleration equals V final minus V initial. Well, let's let V initial be 0, or I mean V initial be 30. Oh, whoa, back up. Going crazy here. So 30 meters per second. That means V final equals negative 30 meters per second, right? So if you take A equals, or actually G equals V final minus V initial over T, and then rearrange T equals V final minus V initial over G. V final is negative 30. So negative 30 minus 30 divided by 10. Isn't this 2 times V initial? Right? If this is negative 10, negative, negative, negative. So then the time will be 30 and 30 is 60. Negative 60 over negative 10. So the time will be 6 seconds for the total time of flight up and down. So if you just want to do half, you take V initial divided by 10. That will be time to the top. Height max. And then V2V initial over 10 equals total time. Okay?